having the same key. User will be, say, like if I'm just transferring a particular secret message to a particular user B. So I'll be giving the message and also the key recipient. So those who have the key and also the message, they can use the key and decrypt the message and read it. So that is the one approach that is symmetric. But in blockchain networks, the cryptographic technique that is used is asymmetric cryptography. You might be aware of, like, it's a public and private keychain. So each node will be having its own public key and also private key. So the nodes that is connected to the network, they will be flooding their public key along its network, so that the other nodes will be knowing which network or which node it's actually trying to connect with. So whenever it sends the message, so it signs with the receiver's public key and it sends the message. So while receiving end, it uses its private key to decrypt the message and see it. So by this way, man-in-the-middle attack and so attacks are actually kind of eradicated. So this technique is again used in blockchain. So now let's move to the other buzzword, hashing. So hashing, if I see, like, to have any particular payload, let's say I have two different payloads. If I want to hash them together, the two payloads will be entered into the hash function, and the resultant will be the hashed element. There is a so here what we are achieving is like we are just getting a fixed length key. So this again is used for blockchain. So in blocks, you will be having multiple headers. So to combine all those headers, hashing techniques is used. So if a particular small value or particular element is altered, the entire hash value will become insignificant. So by this way, we can ensure, like, if a particular person is trying to edit our message, uh, if we have done hashing, then it results into a different value, and we may understand, like, a particular user is trying to alter my message. Okay, so now done with our buzzwords. So let's move on to the blockchain history. So the first blockchain or hyperledger, or what we can say is smart control logic, or so whatever we can say, uh, that was invented by Satoshi Nakamoto. So he invented that in 2008. Blockchain evolved by 2009, 1 year later. So his intent was to have a particular system where no banks exist. So we don't want to rely on any third-party vendor or any UPI gateway system or any bank to do any transactions. So if you want to send any particular money or any currency to a particular recipient, if we have a particular system that has solving our problem, like there is no need of any external party or bank, then it is sufficient, right? So that is how first blockchain came into. So I repeat, like, here no banks or third party were involved. Instead, the direct communication between party A and party B. So yeah, so by 2009, a public permissionless network evolved. That's a BitCoin network. If I say public permissionless, any person can join that network, and it is public. So your information is not maintained there. You are anonymous there. The people will not be knowing, like, how much you are transacting or how frequently you are transacting. So all such information will be known only if it is in the network, and also they will not know, like, who are you. So they will be knowing you as a node. A particular node is asking me a permission, or requesting some amount for my favor. So I'm giving back. I may not know, like, which particular user I am giving to, or from which particular user I am getting my money. Why this Bitcoin? So if you say, like, I'm just getting money from any person, so it seems like it's somewhat creepy. So here the security is not there. In case of public permissionless network, any person can transact, and you may not know who is actually the user. So here the chance is risky, right? Yeah. So but there are many sorts of networks that are emerging. and many policies and rules and regulations have been added so that uh, somewhat we can make the network stable and also um, make the system not anonymous. But basically, the scratch version of Bitcoin network is public and permissionless. So if you see our history, many uh, uh, persons have gone bankrupt by buying the Bitcoins because it may lead to risky transactions or many fraudulent transactions can take place. Bitcoin theft can happen because of hacking. So yeah, so many things are available. So Indian government has made rules and policies, and still they are actually kind of framing the policies for Bitcoin transactions. Now in India, Bitcoin transactions legal. So here you can transact to any user and get the Bitcoin. It is like you just want to download a client. You go to Coin Exchange, Coinbase. So there are some sites where you can download your Bitcoin client and you can start purchasing Bitcoins or selling Bitcoins or doing a mining activity. So which we'll be discussing now. So there is no tax levied for Bitcoin to the current practice. No tax is levied. So like if you gain something out of Bitcoin, government will not be questioning you have earned this, give me some tax because it is anonymous. You don't know who you are transacting to, and you don't know you just invisible. This many problems also arise. Many organizations or some military related items were being it's like identity theft. So uh, for buying some illegal weapons or illegal drugs or getting some advanced high compute machines, they're using Bitcoins. There are other sites as well. If you don't want to reveal your identity and if you want to do a medical purchase, so you don't want to say I'm the person who is actually transacting and I'm requesting for a medicine. You know that you need a medicine that is available in the market. So to just have your identity not disclosed, buy a bit, you have a Bitcoin, just get the medicine by just transacting a Bitcoin to them and get the medicine back. So by this way, good things and bad things are there. So now things are clear with the introduction. So I said there is a Bitcoin network. Let's see how the network look like. Consider the first network here. So this is an existing network where a group of nodes form together a network. Let's say I want to register myself or I want to add to this network. So as a first step, what I'll be saying is I'll identify a particular seed node. Seed node may be any node in the Bitcoin network. I'll ask for the address. Once I get the address, I'll be knowing what are the peers of me. So I'll be connecting to all my peers if I got the address list. Then what I'll be doing is all nodes will be maintaining a blockchain. So which we'll be seeing in a few minutes. So I'll be getting all the list of blockchains that have already transacted. I keep it onto my node as well, and then start transaction. So this is a basic network where if you want to try registering into the network, this is the procedure. Yeah. So you can assume even for tracking a particular full complete history, we can use this Bitcoin network. Let's say if a farmer is having a wholesale business, he's he's spending some amount to send that to the wholesale dealer, and the wholesale dealer will be shipping that to multiple consumers. I mean, middleman in the market, and the middleman again will reach out to the consumer. So if we register everyone inside the network, so we can track how the purchase is going on and how the profit and loss model is calculated. So these are some other additional examples. If we try to use Bitcoins, I mean complete digital currency instead of our any other digital wallets. So now we are just going to see like we argued like we can do transactions and we can form blocks. Now let's say we can see like how this transaction takes place, how the blocks are formed, and how an agreement is happening between the nodes to keep the data in sync. So let's say the first node is having the transaction that is A to B. It says like I just spend 10 Bitcoins. So once the node A transacts to node B the 10 Bitcoins, if the transaction is valid, meaning the node A will be having a particular, it will be having a digital wallet where it has list of Bitcoins available inside. If node A is saying like I just want to spend 10 Bitcoins, it should have the proper balance in its wallet. So all nodes will be knowing the peer nodes and digital wallet balance. So that is transparent. So when a particular node requests for another node, or when a particular node make a transaction to the another node, if it sends any Bitcoins to the other network, the initial step is it will verify whether the current node which is transacting has a minimum balance that it's having. So if it is valid, then it will take that money and it will register in its log. Then it will flood to the entire network saying like I have got the money from A, and I got the Bitcoin 10 Bitcoins to me. And also the A node will be let's say if it is having 10 Bitcoins, it will be 0 now. So it will not be having any Bitcoins in its wallet. So all the nodes will be known like now the current balance of A is 0 and the node is 10. Let's say if both A and B have no initial balance in it. So this is how the transaction is got flooding. So you may argue like why the transaction is getting flooded, why it should not be confidential between two parties, because that is how this network behave. So every node will be having a transaction pool where it will be maintaining the list of transactions happening within the network. So by this way, it can verify whether the transaction is valid or not. As I said, they say it as a UTXO. UTXO is something like unspent transaction output. So if you say BTC 10, it's a UTXO of 10. So if A is sending 10 Bitcoins to B, and if the A have no balance, then say the UTXO is 0 for the node A. Also, I would like to quote here one another thing, like we have in our physical notes. Let's say we have two 20 rupees notes and one 10 rupee note. If we want to transact 30 rupees, so what we will be generally doing? So we will be clubbing all different notes. Like I have one 20 rupee note and two different 10 rupee notes. So I club all these three physical notes and I will send it to the other party. So the other party will be receiving that and he will be giving me back the 5 rupee note or 5 rupee coin. So the same happens here. So any transaction happens that is maintained as a separate entry. So if I may not have complete 10 Bitcoins with me, instead I can have like 5 Bitcoins, 3 Bitcoins and 2 Bitcoins. Let's say if I have this kind of money with me, so I will be sending all these together as one transaction to the node B. The node B will be getting that transaction, and it will sign. It will, if it need to send back any amount back, it can send back. Otherwise, the transaction is complete there. So this is how the record keeping works. So record keeping basically like all nodes should be having a transaction pool where the list of transactions will be maintained. This is to identify if any faulty transaction happens. So main concept of record keeping is, first it will check whether the aggregation of bitcoins will be having the money uh, equivalent that is enough to satisfy the node B. Let's say if it is asking for 10 bitcoins, whether the node A is having 10 bitcoins collectively. So that is one check. And also it will again check like if if the node A is sending 10 bitcoins to two different nodes simultaneously, it should not accept. So the two nodes should not accept like uh, 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 then it will be like the node A is sending 20 bitcoins altogether, which is actually a fault transaction. That is why we kind of have a transaction pool entered in every element. So if node A sends 10 bitcoins to the node B, all nodes will be knowing that node A is not having any further bitcoins to spend. So that ledger is tracked everywhere. So if it tries to uh, send again another 10 bitcoins to some other node, it may know like, okay, the node doesn't have any balance, but it's trying to give me some bitcoins. Maybe this is a kind of faulty transaction. I should not accept it. So this is how the record keeping works. So any questions so far?
Yes, excuse me, sir.
Yeah, please.
Actually, could you please tell me? Actually, I'm very new in this blockchain and all. I'm
Okay.
from electronic branch,
Mhm.
so I've got a good idea. But could you please tell me why we are going for Bitcoin and why we are going for blockchain instead
Okay.
of conventional currency? Why we have suddenly chosen Bitcoin and it is heavily becoming popular? So could you please
Sure,
give me some
sure.
idea?
I'll come there. So
Okay.
I should have shown the applications first. Okay. The first thing is the network cannot be mutable. So it's almost impossible to edit the transaction. If it says like a particular node commits by adding a node into the network, the node may have list of transactions in it. That transactions will not be edited again. That we'll be seeing in the upcoming slides. We have multiple techniques available to hash and digitally sign it, and the creation of the node and adding into the block. So all such concepts will be there. So if we do that way, then what I can assure is the network is safe. So in the traditional approach, you may be charging with some amount of money, a monthly basis or yearly basis. You will be reaching out to the bank why it has happened. So maybe from the bank side, it might be the fault, or they'll be choosing due to customers' negligence, they might have introduced some additional amount or levied additional amount to that user. So we kind of go and reach out to the team, and they will be saying like, okay, this is our fault, or this is any network fault. So they will be committing that, and then they'll be giving out our resolution, right? So here, if we form a robust network, we don't even need any banks here. Instead, like the we can send a particular amount of transaction or amount of money to another node without having any central body. We don't need any banks or any third party solutions like UPI gateway. Instead, the network itself handles that. So you may question like how it is feasible. So if I'm not knowing any user's information and who is even giving me the amount and who is getting me the amount, I don't know. Then how it is useful? Because it is useful in some illegal activities. And if you don't want to disclose your identity, and if you still want to do transaction, you can go with the Bitcoin transactions. But it is not the case that always you are anonymous. This is one variant of the blockchain network. See, this network is public permissionless network. Any person can join this network. That is public, and that is and also permissionless. So here you don't want to register you as a you. So you just come inside the network, just do the transaction and go back. No one will be reaching out to you, right? So this is actually a kind of flaw, though many people are using. Many people like even some for ransomware or as a ransom, they will be asking as a Bitcoin. Say, let's say if you are if your network or if your organization's security is compromised, they'll be sometimes asking you as just give me some bitcoins, I'll be releasing that. Or if you just want to buy, if anyone try to purchase any illegal items, for that only bitcoins are used. And also, like if you don't want to disclose your identity and buy some medicines or do some confidential, you don't want to disclose your identity, but yet you need to do the transaction, you can go with this Bitcoin network. So from the thing what I've said, it is risky, and there are many chances that we'll be losing our money there. But still, this is one of the type of the network that is out there available. But we would not be using this for any bank systems or any GST systems or any private blockchain kind of systems. So we have different variants of network. So that I'll be covering in last 15 minutes. So this is a kind of system. Just have like people come, but they don't want to disclose their identity. Just do transaction, get benefit out of it, then go back. That's it. Does that answer your question?
Yeah, actually, yes. Thank you,
Sure.
sir. And one more thing, if you don't mind, can I ask actually what is hashing? Just hash function or hashing?
Okay. Yeah, sure. So hashing is something like, let me just move further and explain since you asked here. Okay. So yeah. See, this is my single block. So I'll be saying like how we are going to form a block. A block is comprised of set of transactions. Let's say I am having 7 different transactions I have done already. I want to convert that 7 transactions into a block. So I'll be coming over like why we are converting. So I'll be dealing with all those steps. So since you asked hash, I'll just say this one. So let's say we have 4 different transactions here. Transaction 1, 2, 3, and 4. So each transactions, if you give to the hash function, it will give us fixed output. Out. So we take that as a hash 0, and we have 4 different hashes. Then again combine 2 of the hashes to form a hash 0, 1, hash 2, 3. Then again form, like by repeatedly combining the nearby 2 elements of the hash, and you form a hash root. So that is called as a Merkle root. So if you try to, if any node is trying to alter this information, that hash will be changed. If the hash is changed, then block is invalid. So this is how we will be identifying whether a particular node is trying to access your data, or if it's trying to manipulate your data. If the node is trying to manipulate your data, then obviously your transaction root, which we call as Merkle root, will be altered. So if that Merkle root is altered, then the other successive blocks will all be damaged. So see, here I have a transaction root. So this entire block will be having a hash. So that particular hash will be referenced here as previous hash in block 24. So whichever node you try to alter and like you just tried to alter and you altered something. So the from the block number 23, all the blocks that we have in the successive links will be damaged, and we can know that a particular node tried to access 23 and it tried to alter and it have altered. So we might have revert and then have the original value. So that is why we use hashing. So hashing is just a purpose of validating the transactions. So blocks created will be having a hash. Hash will be formed out of transactions, and each blocks will be having a unique hash, and also have the previous hash. If the user tries to tamper the information inside the block, hash will be changed. By that, we'll be knowing some person have been attacking my block 23. I'll be taking necessary actions against it. So that is how hashing works.
Yeah, thank you, sir.
Um,
Actually, is it actually
yeah,
hash actually we use also in C or
glad
C++
that you asked.
code?
Yeah.
C code or C++ code as a predefined user
Okay.
before the predefined user function. And is hash containing any particular address over here?
Yeah.
Is it containing any identity for the block?
It's one of the elements of block. Hash is see a hash will be why we choose hashes because of two unique properties. One is if you have any number of characters in your payload, that will be convert to the fixed length hash. That one thing. Let's say you have thousands and thousands of lines in your payload. You are converting that. I mean the transactions. You are converting the transaction to hash value. So that hash value will be same as like if you have 4 or 5 different transactions in some other. So all the blocks, if you are hashing, the hashing result will be same. So irrespective of the payload length, hash length will be same. That is one unique for hashing. Second one is if you try to alter any particular, if you have like 50 transactions, you are clubbing that together into a single hash and you are representing that as a hash there. If any one of the payload is slightly modified, the hash function gives you different result. It is like it is not near to the hash also. It's like even if you just modify a small particular value inside the payload, the hash function will give you a different value. So by that you can understand okay, this is my old hash value. Someone have introduced payload introduced some payload into it or removed some payload out of it. So my hash function is applied onto it, and I got the hash value. My old hash value and the new hash value is not matching. So some fraudulent transactions have been happened. So yeah.
Yeah, thank you, sir. One more thing, actually, when we are trying,
Yes, one. Sorry
please,
to
please,
disrupt. Kindly you can ask questions at the end.
please,
Arun, you can proceed in your flow,
please,
ma.
please.
Sure. Yeah.
Thank you. Thank you, sir. Can have your queries at the end, sir. Sorry.
Okay. Yeah. So let me proceed next. So we have three kinds of nodes here. So let's say we have in this diagram we have multiple nodes specified. So but still we have three different kinds of nodes. We'll see like the why and for what we are just using that nodes. One is minor node and one is full node and another one is simple payment verification. So in case of first we'll go to the full node. Full node is where it have the details of uh, I explained you the blockchain's header, right? So it has header plus payload information for all nodes. So if you have like what how many nodes we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 nodes we have. So the full node will be having all 9 nodes information and all transactions happen between the nodes. So it have the entire data. So that will be acting as a full node. So in a particular network, full node can be considered like it's a central system, but still we don't want to have kind of central system. So full nodes may be 2 or 3 inside the network. So they hold the complete information about the network. Usually full nodes will be the trusted identities. We make full node as a trusted identities or the nodes that is inside for a longer period of time. We consider that if any node that is inside the network for a longer period of time, we consider it as a valid node and it is having a track of history, so it might be legitimate. So yeah, and simple payment verification node is a partial node. So this again has the complete list of all different 9 nodes, but here the only part is it just have the header information. So what the header information has, it's like what is its current hash, what is its previous hash, and what is its value or some other additional parameters it have, and what is its what is the node's current balance. Say like if it has 4 or 5 bitcoins left, so it says like what is the total unspent transactions inside it. So such nodes are called as simple payment verification nodes. So why this node, why these different variations of node is we don't want all nodes to be behaving as the same. uh, I didn't explain about the minor node. I'll come there. So minor node is something where it actually plays a vital role. So we know that we are actually kind of transacting a particular amount from one node to another node. Yes, we agree that a user can get amount from different user. We also get money from the network also. Let's say we have 9 different nodes, and we also have formed a network. So if uh, how the mining happens is, um, whenever a particular transaction is happening, so all these transactions will be grouped together to form a block, right? That's what I explained. So all nodes will be trying to form that block. Why it is for trying is, if it forms a block successfully, it will be receiving some bitcoins from the network itself. So not only it gets from the user, like any for any transactions, even for maintaining this network, and even for creating a blockchain in the inside the network, the node is rewarded. Let's say this node is having multiple transactions. All minor nodes will be contributing to creation of nodes. Here, let's say if we have 9 different nodes, some of the nodes may say like, I can be the partial node and I can do only validation purpose. I don't have any high compute machines with me. I can just I have only limited computing power. Let me be part of only for validation purpose itself. I don't want to do some computing power, because to do all these transactions and maintaining the ledgers and updating back and creating a node, it requires lots and lots of computing power. So only certain nodes can do that way properly. So those nodes are termed as minor node. So usually, Bitcoin is famous for Bitcoin mining. So people may get Bitcoins from party A to party B, but rather than, because of maintaining the node and mining place, the network rewards itself will give them more bitcoins. So many people now are acting as a minor node, and they'll maintain the network and form the block and get the reward from the network. So by that way, they don't want to spend, or they don't want to put their physical money into the Bitcoin wallet. Instead, they have the computational power. I'll explain what the computation happens. So they have the computational power. Because of the computational power, they can able to form a block. I'll explain how the block is formed also. So they can able to form a successful block, and that helps the network to improve it. So the network is also satisfied, and it rewards the minor node. So by this way, we have 3 different nodes. Minor node take part in creation of the blocks. Full node will be, full node will be having the entire information. It may or may not take part in mining, but it still have all nodes information. And some payment verification nodes, simple payment verification nodes are available. This is another variant where mining will not be happening, but instead, post mining, a result will be formed, right? So that result is valid or not. So we can check that result. So post the mining happens, let's say we have 9 different nodes, and 5 of the different nodes are actively contributing in mining, and a particular node may arrive at the solution first. So mining is a process, I'll explain. So out of that mining process, it acquires a result. So all nodes are parallelly trying, but one node that is tried first and got the result will update the network, say like, I have found the result, and I formed a block. So give me the reward. So right. So particular node is a minor node, and any other nodes that is inside the network can verify that. So we cannot accept like, okay, this is the right result, or this is the right block formed, because many malicious nodes may enter into it, and they may say like, I have created a block. So we should not allow that to happen. So a particular validation checks are applied on top of it. So if the validation is passed, then we say like, a node is successful in creating a node, creating a block. So we have talked much about the nodes. We are just still puzzled about what is the block connector. We'll see what is inside the block. So here is the block. This is the block's header, where it has previous hash value of the block. Let's say if you have a block 21 associated in the chain. So it's the next element. So the previous hash will be one of the parameter inside the block. And when is the timestamp this block is created? As I said, we also formed a Merkle root, that is transaction root, based on the list of transactions available in our pool. We kind of form a hashing on top of it, and we created a Merkle root. And we also have something like nonce value. So this is where the mining happens. So nonce is something, it's a kind of um, difficulty condition. So uh, let me put in a different context. So the network will be setting a particular condition. It says like my hash of the header should be less than this value. So this is how the network sets condition when all blocks or all nodes try to create a new block. So that difficult condition will be very hard to achieve. So nodes will be like they will be having this complete header. The previous hash, timestamp, Merkle root, and nonce. All values are combined together and formed a hash. That hash value should be less than that of the network shared value. Usually, that will be very difficult to achieve. So that is why the minor nodes came into. So they will be finding which nonce value we can alter so that my hash of header will be less than my value. So that is the significance of nonce. Nonce can vary from 0 to 1 million or 1 billion or 1 trillion. So whatever value that may be. So, but it will try iteratively. So it will try for one and try to hash everything and see whether the hash of header is less than value. Then it will try to second and try to third value. So like that, it will introduce the it will vary the nonce value in such a way that the difficulty condition is achieved. So once this difficulty condition is achieved and a valid block is formed, the network will be giving a reward to the node. So you may ask like why this difficulty condition is set, why we need to follow such kind of practice, why the network has to reward. Okay, so for that the answer would be we have multiple nodes in our network. We may not know like which node is a proper genuine node or which node is a normal node, and we also have list of transactions flooding here and there. So we also form a Merkle root, and we have a list of we have multiple blocks, timestamp, and nonce values. But we somehow need a mechanism to say like this is my proper formed block. So many nodes are inside. All nodes are trying to create a block. So we may not give like all nodes with a reward, right? So that is how a difficulty condition is set. It's like a kind of captcha. See, whenever you enter a site, it will ask for a captcha. You just enter it and then you go inside. So the captcha is very simple, right? But here the difficulty condition that they set is very hard. So no people can enter into. So let's say if you have a bank server system, you have also a captcha server running there. Consider the bank server will allow only one at a particular point of time. So multiple people are trying out that captcha value. So the one who enters fast that captcha value gains the access to the node. So the remaining nodes will not be gaining access to. If the node is very sensitive and the node should not be altered by multiple other nodes, only a particular single node should gain that access, right? So that is how this difficulty condition is also set. So the network introduces a particular value, say like this is my hard value. If you just hash your header, it should be less than this value. Just bring me that value. I know that you're maintaining all your transactions, you're creating blocks, fine. But I need to just reward the network that is doing fast. So all nodes will try to create that block. They will be trying different nonce values and finding the hash of the header and also checking whether the difficulty condition is satisfied. If it is satisfied, then what they do is they will update the network, say, hey, I have completed my validation. I mean, my difficulty condition, the difficulty condition set by the network is satisfied. So I am the winner. So it broadcasts. So that network will be analyzing that, and it will see like whether the value is correct, and also it's less than the value. Then the block is allowed to create for that node. So as a result, a particular number of bitcoins will be sent to that node. So usually late in 2009, a successful creation of blocks will be given 25 bitcoins for every successful creation of block. But now it has been reduced to 12.5 bitcoins. So it is like for every 4 years, they are reducing the Bitcoin value by 2. So in 2009, it was 20, 25. So now it has reduced to 12.5, and in future it will be reduced to 6.25. So this is because more and more users join the system. So we want to split that amount to multiple users, right? So it's a kind of pyramid structure where you might hear about the multi-level marketing. So the same structure here. So whichever node comes first and have, they might be having benefits reaped more. So if any new user coming and then they are using, they will be having more mining rewards. As time progress, many nodes come in, multiple people come in, many blocks have been created. So as many computing power is also there. So as and when the network is increasing, the number of bitcoins offered per reward is also decreasing. That is how the current state we have. So I explained you previously. So let me iterate it back. So consensus is like a agreement. So I said we have transactions and also creation of transaction and also a block. A transaction is nothing but a node A is transferring some amount of Bitcoin to another party. So to that to be success, first it verifies whether it is coming from the valid address, whether it is validly signed, whether it's coming from A or not. So it will just see like the private key of the um, the third party that is signing, whether it is valid or not. Even it should not be private; it can be a generic signature, and it also verifies whether it has sufficient balance. So if these three conditions met, we can say like it is a valid transaction. So like this, many transactions happen. Say like 7 or 8 transactions happen. So after that, block is for every block. I say like it's for every block the creation time is 4 minutes. Okay. So within 4 minutes, how many number of transactions carried out by the node, it will be tracked inside its ledger. So once the previous block is complete, the new block is about to create, it might be having list of transactions in its pool. So it will take all those transactions and try to form a block. So once the block is successfully formed, it will be rewarded. So then now the transaction pool is empty again. Now it again tracks all other requests. For another node to create a new, it will again create 4 minutes. So with that remaining number of 4 minutes, all the transaction that is happening will be maintained in again transaction pool. So once the block is complete and a new block creation time is started, it takes all the transactions again and again forms a block, do the mining process, get the reward. So this is how it works. Okay. So now we have seen like uh, creation of block is now it's clear. So I'll iterate like um, list of transactions from the transactions pool are fetched, and uh, Merkle root is formed. The header hash of the header with previous hash timestamp and the Merkle root formed out of the transaction, and the nonce value what we compute by iterating multiple values and also making the condition satisfy. We created a block successfully for every 4 minutes. Okay, it's done. Now we say to the network that my block is ready. But as I said, the block may not be true, and it may not be holding the value right. So there should be some kind of validation should be happen. This is where the SPV node comes. The validations to happen, it just takes about microseconds. But mining to happen, it takes many number of time. Like it will be in seconds or minutes or hours. So mining is a complex process and it requires a lot of compute. But for validation, it's just a matter of microseconds. So what it will do is the network will check for the hash. So if already it has the same hash, then it will reject that node because the already same hash is already present in its network. So it is trying to duplicate it. So it will reject. So the hash value should be brand new. And also the block 23 has previous hash, right? So the previous hash should be equal to the block 22's hash. So the hash value should not be changed. So that is the another condition. Then the another condition is the difficulties condition should be satisfied, because by introducing multiple nonce value, we made the hash of header to be less than that of the difficulty value, right? That value should be matched. That is the third validation. And the timestamp of the current block should be greater than that of the timestamp of the previous block. So it is ideal that the older block 4 minutes lagging and the block 23 will be C plus 4. It's like after 4 minutes it have created. So the transaction timestamp should be greater. Obviously it should be greater. So if all these conditions are satisfied, then it will update the blockchain new number and it will broadcast to the entire network. So now once validated, the validated network post validation, the block will be broadcasted to the complete network. All nodes will be adding this block to its chain. So it is that the blockchain will be maintained in every node. If you see here, all nodes will be having an individual blockchain. So all nodes will be having a blockchain. That is how I explained here also. See, it says like once a new node is arrived, it is forming the mapping and it gets most recent blockchain. So here you may you should understand that every every node is having a blockchain. So all node is tracking the blockchain. So whenever a new node is added, the blockchain information, what it has, the every node, that should be propagated here. And this node will be sending a blockchain here, and this is also sending a blockchain here, and this third node is also sending a blockchain here. All blockchains are similar, so there is no fraudulence there. So I am trusting all these three parties, and let me say like, okay, let me have this as a base blockchain, and I'll start creating new transactions and add further blocks, and I'll broadcast it to the further networks, and all the networks will again be updating with the blockchains. So this is how it happens. So any network, any node that adds a new block to the existing blockchain, it sends or it broadcasts the complete blockchain to the entire network, and the entire network updates its own blockchain. Okay. So now we are end with the validation part. Okay. So there are some loopholes here. So there are some challenges there. If the system is perfectly working, if and only if the transactions are legitimate and the nodes are legitimate, there is no malicious nodes introduced, all are going smooth. So far nothing is going to happen. Say if you have a particular node which is having a malicious intent, it's trying to alter the transaction. So when it can go wrong? So usually I say like the blockchain is very robust and we cannot able to alter because of this hash property, but still it can able to attack the network and change the value. But when is that attack is happening? That's how we are going to see now. Let me go back to here. Okay. So what I will be doing is, as a miner, I take lot of computing power to solve that hash property, right? So what I will be doing is, let this node act as a leader. So within this blockchain itself, one particular malicious node or any significant node that will act as a leader, and it will inform its peer like, okay, I'm going to compute the nonce value starting from 0 to 2000. You compute from 2000 to 4000. You compute from 4000 to 8000. So like that, it will split its nonce values, and it will all check for the difficulty condition. So whichever node it finds, it will update that leader. So the leader will be again sending back, this is my nonce value and this is the hash I have tried out. So once I got that information, I will be saying like, this is my mining information I got, and the network will also be. So this happens actually. So when in a particular set of network, a group of nodes will come into a particular agreement, and those nodes will share the hashing values, and they will be having a mining, find the result and give back to the leader, and the leader gets the reward. So by this way, that node becomes a monopoly. So this is what I say, like it's a 51% attack. So if the node has 51% of its node as a malicious node, then the network can be compromised. So significant improvements have been taken to not attain this percentage. So mostly, if two-thirds of the network is genuine, then it's good. But earlier it was even 51% of the node gains access to the network, then it can alter the sequence of the blocks. Since it is becoming a high monopoly and it is of energy efficient and compute heavy, it can get all its rewards. So if it gets more and more rewards, more and more blocks will be added to it. Also, I said like it will become well registered node. So if many blocks are created on a particular node, we assume that it's a legitimate node. Then it try to alter the information, and the information will be flooded back to the other nodes, and the other nodes will be updating with that. So we should not make this happen. We should pose many conditions, validations to see whether a particular node is becoming a malicious. If we found that, we should chop it off, or we should remove it. So blockchain community is doing that. They are actually kind of they kind of have a strict rules, like a network should not have 51% access, but still there are hacks happening, right? That is because of this 51% attack. So to overcome this challenge, another variant of blockchain Bitcoin network is introduced. That's Byzantine fault tolerant network. Here it's not 50-50. Instead, the two-thirds of the network should be genuine. So if one-third of the network is faulty, then it's fine. Still, we can able to retain the block. But if 2/3 of the network it exceeds the 2/3 of the network, then it again leads to uh, the faulty network. But ideally, it should not happen. That is how our rule should be. Okay. So any questions here? So we completed the Bitcoin anatomy and block architecture. So now we are going to see about the applications where this Bitcoin used and other variants of the blockchain. So I'll take another 15 minutes. Hopefully, it will be complete. So any questions so far? Anything you want to get clarified? Okay. Now let's go to some of the applications. So this is a Swift network. Here you can see multiple governing bodies like insurance companies, government institutions, stock exchange, corporates, everyone. So can this form a Bitcoin blockchain? I think it should not, because we should be knowing which is the payment system it is integrating to, what is the corporate it is accessing to, who is its trustee, and who are the market data providers. So all this information should be known, and who are the senders, who are the persons who are transacting or making the network, making part of the network. We should know very clear. So the Swift network cannot be a part of Bitcoin network. Bitcoin is a network where it is public and permissionless. But Swift, it's a consortium network. I'll come to what is the consortium network. But just keep in mind that Swift cannot be a Bitcoin blockchain, because we should not compromise the anonymity, and we should not compromise the data transparency. But if you see the Bitcoin network, all data is accessed by any other nodes. So there is no hiding there, completely transparent. And we also see like there is some possibility to immutability as well if the 51% attack exceeds, or even in Byzantine fault tolerance, if it exceeds 2 bit of the network, and it again scales the control. So there is some immunity possible. And we also don't know who is actually transferring this amount or who is being part of the network. So such kind of scenarios will not be there for Swift Bitcoin, I mean Swift blockchain. So ideally, the Bitcoin network is not suitable for Swift. That's what we are arriving to. Okay. So far, we have seen public permissionless network, that is Bitcoin network. So what is public permissioned network? So this is again any person can join inside. It is visible to all, but it's a permission network. So here, anonymous users cannot be part of. So earlier in another variant of blockchain, which is a Bitcoin network, where users will not reveal their identity, they just do transactions. But here, as part of the GST blockchain, which is about to happen in some years, so many projects have been going on for tracking this GST system. So as I said earlier, we can track till wholesale to retailer, wholesale to the end user customer. If the wholesaler is sending to multiple middlemen, and the multiple middlemen is sending another to another multiple middlemen, and then it is finally reaching the consumer, right? So if all these uh, transactions are captured and tax system is levied on top of it, we may not miss out any transactions that is happening. So in our current systems, since we don't have such kind of robust system, we tend to lose some of the uh, taxes. Many people as not part of the GST system. So still many people are having GST account link, but yet some of the systems they'll be saying like because of this I lost this much of money, I lost so much of money, so GST system is not good. So many that process is coming, right? So to just unreveal all those items, if we just kind of form a particular network and track a particular product's price and fix tax based on that. So if a wholesaler is trying to give to a middleman, a particular GST will be applied, and for that goods and services, they will be applied a particular tax. So for and the chain continues. So we may able to see like the history of transactions that has been happened, and based on the history, we can avail taxes on them. So you can see here the accountant general and facility center reps, help desk. So these are all physical entities, right? Who enter the GST. They kind of now maintain our GST accounts and link everything. So as a futuristic state, we don't want such people. Instead, those people will be mostly they'll be giving their ideas to IT. The IT will be forming a network, a robust network, where it has the taxpayer and GST Council, RBI, multiple banks will be part of the system, and they will be governing that body. And the information is passed to every other bodies. So RBI will be knowing what the individual is actually um, having a transaction, or even he can the GST member who has been registered to the network, he can track how his goods and services have been progressing. It's not only that banks and RBI will hold the detail. Instead, a common man, as a common man, I can see like how my raw material is reaching my customer. What is my initial price? When it reaches consumer, what is the price? So I can able to track the complete system. So here, as I will be again adding here, data is completely transparent. So you can see any data. You can see like how my transaction happens from start to end. But one thing is which is differing from the Bitcoin network is anonymity. So users should register. Any person can actually come and register. That is why it is said as public. But the user should give its identity. So that is how this public permission network works. So this is another variant. So now let's move on to some other variant which is still more robust. So here data transparency is there. We may not expect like all data can be accessed by all, right? So there are some cases like some of the information has to be confidential only to certain bodies like RBI or banks, and only such information has to be preserved, and other systems has and some other additional informations can be sent to other people. So that is where the private blockchain network arrives. So now Reliance is trying to achieve the blockchain system. Let's say Reliance has multiple subordinate bodies. They have Network 18, Geo, and Reliance Life Sciences. They have many such systems. Here, what is I can say is that there is no transparency here. What I can say is to the outside network. So within this network, transparency is achieved, but outside this network, there is no transparency. If it also that no node can go and enter into that Reliance system. Reliance will be saying like these are my bodies, and these are the bodies I can share the information. So here this Reliance industry forms a central body. It acts as a controller. It shares the information to Network 18, Geo, and Reliance, and also Network 18 gives back the results. I mean, within themselves they have a communication link. So outside nodes they cannot able to access inside. So this is a good way of doing a blockchain. Many organizations for tracking their customer supply chain, they are going to introduce this private blockchain network. So this is going to be very popular among corporates and many other government sectors where they want to keep their data under silos. They want to have such private blockchain where you cannot just like that go and register. So you should not be an anonymous user. You should be a well-known user. And also the data transparency is happening only within that network. It is not happening outside the network. So this is an example for the private blockchain. So now let's move on to interesting blockchain network, which will be the future. So it's a consortium blockchain network. So what is this consortium blockchain network? So here you may not have a central body like the Reliance Industries. So here the Reliance Industries is acting as a single central body, and it floods the other data information to multiple other entities, right? So here, if we make any one of the entity as a central body, there might be some risky happening that that particular system might become a monopoly. So in case of private organization, if that becomes a monopoly, that is fine. Even if Geo is having some data and the Reliance industry node is having lots and lots of data, and it's forming more and more blocks, and it's becoming a complex blockchain, and it achieves the 51% effect, then it's fine because everything is inside them. So no new networks are introduced, even though if it is if the nodes are increasing and if the blocks are increasing for the Reliance industries, that is fine because those are all trusted entities. But here, if you see, we have banks like State Bank of India, ICICI Bank, Axis Bank, HDFC Bank, or Reserve Bank of India. So we have lots and lots of banks there. So how we can give them a weightage? So can we give like Reserve Bank of India as a full weightage where it can control all other banks? So Reserve Bank being the head entity that controls SBI, HDFC, Axis, and ICICI, will it be an optimal solution? Even we cannot trust Reserve Bank, right? Reserve Bank can also do some malicious activity, or it can do favor of one particular bank. So let's say I'm opening an account in State Bank of India. Reserve Bank of India has some terms and agreements, and some internal employees, they try to monopolize the Reserve Bank of India, and it routes all the requests to HDFC and ICICI. Then State Bank of India will be having less number of blocks, and ideally it will be removed out of the blockchain. So it should not happen. So we should kind of have a controlled system where the complete access is distributed. So it should not be a monopoly. Instead, a shared access between the network can be established. Let's say Reserve Bank of India can control ICICI, SBI can control Axis and HDFC. So depending upon the rules and regulations and strategies that we employ, we can have a hybrid hierarchical structure. So how it should be controlled. Even Reserve Bank of India can be monitored by some other banks. So whether it is doing correct or not. So other legal and technical panels will be monitoring RBI. And also one another thing I would like to quote here is all data will not be shared in between. So only some of the details like customer KYC, credit information, and repayment patterns are shared. See, the idea of the India lending blockchain is to identify the fraudulers. I mean, like if I take a loan in one particular bank, and then I go and again take a loan in some other bank, so it might leads into a risky factor. So then bank will not be knowing whether he might have got loan in the previous bank. Yeah, we have seen many cases like a particular person is getting loan from one bank and repaying the loan in the another bank. So such kind of activity should not happen, and we should not allow people to get more and more loans to the multiple banks. If HDFC, if you are reaching out to HDFC and we ask more and more loan, and he found that we are a risky or fraudulent guy who will be escape, who will tend to escape, then it should inform other different banks that don't give amount to him. Any additional amount to him because he might be a fraudulent guy. So all these banks will be having a chain, and it helps them to give the lending in a correct fashion. So because of this, other people will not be impacted. So it will not give all the information also. So it will just give the customer KYC information and credit information and repayment patterns. So if the repayment patterns is shared to all other banks, then they will see like, okay, he is a good guy. We can give him some amount so that he will repay back. So as I said here, there is no supreme controller. So RBI is controlling ICICI and RBI Risk Department, and Credit Bureau is again controlling RBI, SBI, and HDFC. So still this is in construction. So hopefully in the next decade or 5 years or 2 years, we can see India lending blockchain. Even now, people are actually kind of tracking their using their CIBIL scores, and also they are tracking the purchase patterns. But those are kind of manual, and some kind of integrations are there. So by introducing this consortium blockchain, we can achieve that in a seamless fashion. So here, if you see the advantages here, no network is actually acting as a supreme controller. Instead, every network, every node is having its own power, and they have its own verification schemes. That is one. And here as well, if any particular bank has to register into this India lending blockchain, they must register as a known entity. So any bank cannot be come and join as an entity into the blockchain. That is why in recent news you might be hearing that most of the banks has been clubbed together. So because we don't want to maintain all such banks under consortium blockchain, instead that is why many acquisitions are happening between banks. So we don't want more banks. So we can have limited 10 or 15 different banks where the India lending blockchain will be functioning smooth. So I hopefully like last year they have introduced like these many banks will be closed, or the banks will be merged to the another bank. So we might be wondering like why they are doing. So they actually kind of have this as their thought. So they kind of form they need to form a consortium blockchain, and they want to set rules accordingly. So they have done that. So hopefully like you have an enough idea like how this 4 kinds of network behaves. So to reiterate everything, I've just put a tabulated form so that we can have a glance here. So whenever I say public, just imagine that as a BitCoin network. Whenever I say permissioned, imagine that as a GST network. Whenever I say private network, imagine that as a Reliance one. And whenever I say consortium, you can think as that offers a India lending blockchain. So anonymity is where you come and register as you. So in public, is there any anonymity? Yes, because like you cannot be identified. So you are anonymous. You are not you cannot be identified as you. Sorry, I said it wrong. Anonymity is something like you you are not identified. What is this? Okay. Okay. So you are actually kind of anonymous. You are kind of mystery to the network. So that is public. And other permission, private and consortium, you should register as a user. And next we come for transparency. Transparency is completely yes in public. Data is shared left and right. So any network coming, any node come and joining the network, data is shared completely. Blockchain is shared completely. But in permission, it is not. Only it is shared within that group. It will not sharing to the it will not be sharing to the outside network. Because it's the same case for the private. But in consortium, as I said, even though banks are together, only KYC details and repayment patterns are shared within the banks. Some other data are kept in silos that will be proprietary only to the banks. See, the purpose is India lending blockchain. So to identify the faulty customers, these are the right informations I can share between the banks. I don't want to share my complete information, or the bank don't want to lose all informations to all other banks. So it just kind of only share essential information to the other parties and make that network as a consortium. Next, we come for immutability. Immutability is uh, the chance of modifying your data. So in public, there is a chance because 51% attack can come, or even 2 by 3rd of the network uh, uh, can be reached to a malicious node, and the data can be immutable. But in the permissioned network also that is possible, since there are more and more nodes. You are giving just a permission, but still it has access to lots and lots of data. So the immutability is possible there as well. But in private network, it is strictly not possible. So here it's you cannot able to alter any information. So all are agreed into its network. So it is not mutable at all, immutable at all. Sorry, it's not mutable at all, because any network inside the network can only access, other networks don't have access into it. And for consortium, there is a slight chance. So even for India lending blockchain, which is a complex project, still the immutability is there. This is why, because it can immutable only the shared data. So what shared data is we have sent the customer tracking pattern, and customer repayment pattern is shared. So one bank is finding that he is not paying well. So he should inform other banks that he is not paying well. So he will be writing to all other different nodes. So the essential data which can be edited can be edited. So a part of immutability is there as well in consortium. But the private data under silos of each banks will not be altered. So some of the bank balance details or customer details will not be altered. Instead, customer patterns can be altered based on the uh, uh, paying pattern. Now let's move to efficiency. So I didn't talk about efficiency much. So efficiency is, let's say if you have 9 different nodes, if all 9 different nodes are competing for the mining process is taking place, and one particular node wins there. So 8 other nodes efficiency is wasted, right? So that is common in public network. So public network, many people will be there. All will be trying to compute, and all will be trying to create a new block. But most of the networks will be failing, because anyway, even if we have 1 million of nodes, only single node will be forming a block. Or if it is far apart, then what we can do is some particular nodes, some group of nodes can form a block, and later on, once identified, whichever node that is old, that will be given high priority, and the other nodes will be rejected. Even though if it is rewarded, because of the complexity, it will be rejected, that node. So in case of permission, private or consortium, every network will be under, every nodes will be under a small network. So permission, it seems like only a set of pool of nodes will be inside that network in private as well. And even in the consortium, 10 or 15 banks will be, or 10 or 15 banks plus other government regulating bodies will be there. So those nodes will be taking part of the miner node. So here as well, the efficiency is good because very less number of nodes are carrying out the mining. So now let's move to confidentiality. So confidentiality is low here, public. So if you go for public network, it is very low. And in permission, it's okay. In private, it is very high because it is not interacting to any other nodes outside. And in consortium, as I said, a part of data is leaked inside its network, and some of the data are under the silos. So it's high. Now let's talk about throughput. So throughput is something that it is actually directly inversely proportional to efficiency. So if it is directly proportional to efficiency. If there is no efficiency, then it is ideal that the throughput is very low. And in permission, it's medium since a group of nodes are there inside the network. And in private, even all nodes will not be part of the permission network. Instead, a particular group of networks will be part of the network, so the throughput will be high. And even for consortium, only 15 or 20 banks will be there. So there the throughput is high again. And what is the finality turnaround time? So the turnaround time is to create one block. What is the time required? So that is the thing. So here, if in case of public, it will be very high because millions of nodes take part in that mining, and many nodes will be computing the nonce value. And since the million nodes are transacting, the challenge or the difficulty conditions will be set very hard. So to track or to crack that difficulty condition, it needs lots and lots of computing power. And to create one final block, it takes lots and lots of time. So here in public network, it is very high. The same case in permission, it's medium. So since a group of nodes are there and some permission group of nodes are there. So here it is minimum because the number of nodes that is interacting between themselves is comparatively lesser than public. Then in private, it's very, very low. So whatever network you have in your network is your nodes. So Reliance groups will have their own nodes inside. So within that, the conditions are examined. It's not 1 million versus some small number. So always the small number wins, right? So private network, the finality tat is very low. And in consortium, it is low. So here as well, we don't have limited bodies, but still we have multiple banks and other government regulatory bodies. So here the finality tat is comparatively low. So hope you might have got some good idea about the different networks and particularly how the BitCoin network works. So you might have got the idea about how the GST's blockchain will going to happen and how the organization is going to transform their business using the private blockchain. Because private blockchain, since the data immutability is not possible at all, so it cannot be mutable, and also it has very high throughput. Blockchain is having a very high intake in the private sector. And you can find multiple government projects around consortium networks. One of the first arriving variant is India lending blockchain, which you would be hearing soon. So yeah, so these are the network types and these are your learning outcomes. So any questions, Steve? So time for questionnaire.
Excuse me, sir.
Yeah, please.
Actually, when we are joining a network, so we are trying to identify a seed node, and then we are getting an address. Then
Yeah.
who is giving the address? Is it getting from the block, or who is creating the block, or who is organizing or controlling the block?
It is actually the network. So that network will be giving the address. So whenever I start my Bitcoin client, I start using the Bitcoin client and I'll register. It's not registered. It's an anonymous registration where you find the seed node. So what you are saying is like how you find the seed node, right? That is what you're asking.
Yeah, yes, please.
Okay. Yeah, the seed node
And
is
who is giving the
something.
address actually? Means who is, so who is controlling the network? Is there any organization controlling the network, or
It
automatically
is.
network is giving the address? Yeah.
You just need to find that seed node. See, you might have heard like in Swiss bank, any particular person holding account in bank should refer another one, right? So it is like if a particular person tries to join a particular network, uh, he should kind of have some authority to say like he's okay, he's a legitimate guy, he can able to join this network. So some authoritative person can, or the person who is inside the network can push the address to the network. I mean, new node. This is one way. And the another way is we have multiple sites available, like coin exchange, Coinbase, where we register us as an anonymous user to the network. And the Coinbase acts as a client. It will search for the seed node and it will give back the address to us. So either way, it is possible. So either you can very well find the seed node in prayer and you can directly join to the network and explore the multiple nodes, or you can use a third-party site like Coin Exchange to get the seed node address and link to your network.
Hello, sir. Hello, sir. Excuse me, sir.
Yes.
Sir, may I know what is the difficulty level to achieve the 51% attack? Is it easy or is it hard to do?
It's hard to do. So, yeah, see, that is how the network decides. See, in case of public permissionless network, the network itself sets a very difficult condition that it cannot be achieved at all. So you will take lots and lots of computational power to achieve that. So that is how a single node is not able to crack that hash. So it is trying to distribute that load to multiple several nodes. Let's say you have millions of nodes. Inside that, your nodes itself have like 50,000 nodes. So your 50,000 nodes will be distributed your hash values, and all different combinations have been taken part. And if you found the value that is less than the challenge value, then the one of the node which you try to increase your Bitcoin currency will be notified, and that will propose that to the network. So the network will again reward your node. So this is how the mining is happening. So because the current players in mining, right, they invest some amount in computes. So they just like that, they cannot able to get the Bitcoins. They invest heavily, like they choose the choice of nodes that they are attaching to it, and also how they are having a strategy like if you got the header hash value, just try to access, get more and more your nodes into the network and distribute the load there, and then you achieve a monopoly. So that is how it's like a kind of what to say. Um, uh, so it's a kind of who wins first. Yeah.
Yes, sir. Sir, may I know one more question?
Yeah.
Sir, what can be the end point? Actually, sir, I read yesterday article that it was showing that wallets are the end point. So may I know what are the other end point, and if little bit about it, if you know something.
Wallets are one endpoint. So actually, like we completely have kind of digital wallet concepts, and
Yes,
we
sir.
also have many API level authentication as well. So if you just look at the blockchain architecture itself, it has 5 different layers. So the layers would be like mm, it's like just a second.
Yes, sir.
So it has something like a UI layer and an API layer and hyperledger layer and the backend layer. So it has 4 different kinds of layers in every blockchain network.
Yes, sir.
So the UI interface layer is a layer where any person can access the digital wallet. So digital wallet is using the API and consuming that API to have the balance listed there. You can use the API directly as well. So as I said, one of the client has a coin exchange. You can have, there are multiple sites out there and multiple variants of digital currencies as well. See, digital currencies, one of the digital currency is Bitcoin. So we may have multiple currencies as well. So Ethereum,
Yes, sir.
and we have lots and lots of currencies out. So though for each of the currency, they will be having a particular user interface associated to that, and also wallet and some servers which they act as a third party to find the seed nodes. They will be also helping us to kind of do an interface between the node as well as the network. Yeah, but
Thank you,
as you
sir.
said, I really like wallet service.
Yes.
Yeah.
Hello, sir.
Hello.
Yes, please.
Hello. Excuse me, can I ask
Yeah,
a
I can.
question? Hello.
Sure, sure.
Hello.
Yes, I can hear you. Yeah.
Yeah. I just wanted to ask, in India, where the blockchain has been successfully implemented.
Uh, Actually, like to my knowledge, what I can say is like still systems are being in practice. So they have partnered with IBM and Infosys to kind of they form a GST blockchain and India lending blockchain. But still, some of the startups and some of the fintechs organization, they are kind of introducing a private blockchain, and they are see the blockchain is safe under the silos. So as for the private network, it is completely safe. So the other variants, they are still trying out, and lots of trial and errors will come. So since it's dealing with money, they are taking into care more care, and then uh, just they are trying to release a foolproof system. So if you say the answer would be private blockchain, there are many fintechs they have implemented, like Reliance. They are the pioneers there, and the other kinds of variants still it is been in progress. Hopefully, like you will hear in another 5 years, India lending blockchain and GST will be out.
Thank you, sir.
Yeah.
Sir, so one more question, sir.
Yes.
Hello, sir. Sir, how can you find the malicious node from the million or trillion number of nodes?
Okay. So fine. So okay. So here, because I said like there is a concept like Merkle root. Okay. So how can I, when a malicious node enters, what it will try to do? It will try to alter the value, right? So if let's say I'm having a block 23 in my system. So like this block 22, 23, and 24, I have these sets of blocks in millions of nodes. Agreeing, right? So let's say I am a malicious node. I am also having this block 22, 23, and 24. So first, what I will do is I will try to alter my own block. Then I will try to spread to all other network. So first, I will be introducing some fault here in 23, and my hash value is getting changed. Because of that hash value change, my successive blocks will also be affected. Since this hash value is changed, the link is broken here. So let's say I have 80 blocks. In my 20th block, I try to alter any change. From my block 20 to 80, all will be affected. So as a malicious node, they will not do that. See, if they try to attack the oldest block, they will be get caught easily. So usually they will be trying out in last 3 or last 4 nodes. If they are having high compute power, if they can able to alter it and also broadcast and make the network also believe that this is the latest updated network, they can still do.
Samliki,
Yeah.
sir.
Uh, anyone ask some question?
Excuse me.
Okay. Yeah. So let me continue.
Okay, if none
So
of you are
here,
having question, we can end the session today. Thank you, Arun.
Thank you for your efforts. We will meet tomorrow morning. Tomorrow session 1 starts by 9:30.
Sure. Yeah,
The
thanks,
link
team.
will be the same as today's link, session 1 link. So all the participants are requested to attend the session 1 link, what we have shared through WhatsApp group. Thank you
Yeah,
all. Thank you, Arun.
thanks. Yeah, thank you, Mepco and participants and faculties. Thanks again.